Well, this one looks a little interesting. In 95, we have radicals in the denominator, so we want to rationalize this denominator, and we'll do that by multiplying by the conjugate, which turns out just to be what's in the numerator. So let's write this. We're going to get the square root of r minus the square root of s over square root of r plus square root of s times the conjugate of that bottom, right? We're multiplying by 1. Square root of r minus square root of s, square root of r minus square root of s. Let's just stop and think about what we're doing. We're given this original expression. We're going to multiply by 1, and the one that we choose to write 1 in the form of the conjugate of this denominator. This is a plus, so this is a minus and a minus, right? Now this is just 1. So we're not changing the value, but we're going to change the appearance. So what we're going to do now is multiply these terms here and these terms here together on the top. So let's just do this. So we're going to get the square root of r times the square root of r, right? We're going to do first and first, outer product, inner product, last and last. So first and first, square root of r times square root of r is r. Now, the first and the last, right? The outer product. They're both square roots. The r is under the radical, the s is under the radical, so we can multiply them under the radical. We've got a positive and a negative, so this is going to be minus the square root of rs. So we've done first and first, outer, now we'll do inner. Negative times positive is going to be negative, and we have an s and an r. They're both under the radical, so we can multiply them together under the radical. I'll write this as rs, s times r times s, same thing. And then we can do the last and the last. Now a negative square root is going to be positive, and it's the square root of s times the square root of s. Square root times itself is just s. Over, in the denominator, we're multiplying conjugates, and we know what to do. We square the first, put a minus sign, square the second. So if we square the first, we're squaring the square root, the radical comes off. Right? Square root, the radical comes off. Put a minus sign, square the second, that radical comes off. We can do a little bit of work here on the top. We've got minus one of these and a minus another one of those, so this is going to be minus 2 of those. So we're going to have r minus 2 of those rs square roots plus s over r minus s. And that's the best we can do. That's our simplified form, and we're done. Now this problem's a little bit different than the ones we've been doing. This denominator is already a rational number, so we don't have to rationalize it. But what we do want to do is simplify this whole fraction. Now we know how to simplify fractions. You factor and cancel. So let's think about this. What's common, if anything, to the top? What's common with 15 and 3? Well, there's a 3 common. So let's take out that 3. So it's going to be 3 times, and if you take out the 3, what's left is 3 times what is 15 is a 5 plus, now there was a 3 here, we removed it, so what's left is square root of 7. The whole thing's over 3. And now you can see that these 3's cancel. 3 into 3 is once, and you just are left with this 5 plus square root of 7. Now we can go just a little bit further in case this is bothering you, this factored form here. If we had something like this, what would you do here? What if we had 15 plus 3x instead of the radical? What if you just had an x? So now you can see that there is a 3 common to both, so what you're going to write is 3 and 15. Right? How do you know what goes in here? You do a little division. So it's going to be 15 divided by 3, which is 5, plus 3 divided by 3 is a 1. There's just an x left if you take that out. So we'll have 3 times 5 plus x. But in our case up here, the x is just the square root of 7.